7, lesson 3. We are still talking transformations, but now we're moving on to similarity. Okay, we've talked about congruent means they're the exact same size and the exact same shape, but similar means that they still have to be the same shape, but they could be larger or smaller. So now we're incorporating not just reflections, translations, rotations, but also dilations, because when we dilate something, either making it enlargement or a reduction, it will be similar. It won't be the exact same size anymore, but it's still the exact same shape. All right. This is just kind of cool. It's not as cool in the copied picture, but if you have your book open, the fractal is really cool. It starts really little, and then they use the same exact portion, and then they just get bigger and bigger as it goes out. So it's really, really kind of neat. So just have that picture on there for you guys, but it does look cooler in the book because it's in color. Okay, so similar. How do we identify similar figures? Okay, well, they're similar if you can obtain the second by a sequence of transformations and dilations. Okay, so it includes the dilation. How do we determine? Well, take a look down here at example 1. They have to, since the orientation is the same, transformation is the translation. So translate D, E, F down to and 5 to the right, so that D maps onto G. And then they compare the ratios. So take a look. They go HG, which is right here, and they put that length, which is 8, over its corresponding length, ED, which is 4. So a scale factor of 2, or 2 over 1. In order for it to be truly a dilation and truly similar, all of the corresponding sides have to be in the same ratio. So then they check the other two, GI over DF was 6 over 3, which is 2, and then HI and FE, which, by the way, to calculate, they had to calculate using the Pythagorean theorem, because this is a right triangle. So 3, 4, they knew that 3 squared plus 4 squared equals 5 squared, and then this is 6, 8, and that's 36 plus 64, which is 100, and the square root of 100 is 10. So they had to calculate that using, they didn't say that, but that's what they used. Okay, so in order to calculate or determine if they're similar, you have to make sure you check every pair of sides. So take a look down here on slide number 3. We see 2 rectangles. They're asking you to determine if they are similar using transformations. All right, so there's a good chance they use rotation here. So that's what they're saying, 90 degrees clockwise, so that W is around W, so that it's orientated the same way. So that would have put it as rectangle WXYZ. So 90 degrees clockwise, that puts it right here. All right, V, U, and T, and then they check the sides, which is 3 to 4, and 3 over 4, and then this was 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6, 7. And we have to determine if they're the same. They said no, because they're not. And if you remember, we can check cross products. 4 times 5 is 20, and 3 times 7 is 21. Since they are not the same, those two ratios are not equal. So they're done. They're not similar. Okay, and showing your work and explaining needs to probably include that work with the ratios. So let's do a couple more of these. Take a look on slide number 4. We have an A and a B problem. So in problem A, we have 2 right triangles. There's a good chance they could be similar, and I would say probably a reflection involved here and a dilation. So let's check our ratios. Now, since it's a right triangle, technically I really only have to check ST and PQ, which would be 3 to 6, right? 3 over 6 or 6 over 3, that's 1/2. Because if UT is 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is also 1/2 because it's a right triangle. Guess what? So are the hypotenuses. Yeah. So they both have a scale factor. So we're going to explain similar, and we are going to reflect to the right and dilate by a scale factor of 2 because it got bigger. Now, if you said reflect to the left, that would be this way to this way, and your scale factor would have to be 1/2 because it didn't really say where you should start at. All right, so let's try B. They look like they're pretty close. Let's start with AB is going to correspond to DEF, so that's 3 over 2. And then we have AD, 1, 2, 3, 4, 5, and 1, 2, 3, 4. So 5 over 4. And guys, I can stop right there because there is no way those two are equal. Check cross products if you need to, but that's 10 and that's 12. So they are not equal, so not similar. And it's that simple. If you wanted to show me that they are not simple, that works just fine with me. All right, we are on the back side now. Well, if we know they're similar and they give us a scale factor, we can use that scale factor without anything else. So remember, this is a review. We've seen this before. If the scale factor is between 0 and 1, that's actually going to be smaller. We call it a reduction. If it's equal to 1, it's the exact same size. But if it's greater than 1, it's going to be larger, and that's an enlargement. Okay, so check this out. These are the type of problems you're going to see. It says, an art show, we've got different size prints of the same painting. The original print measured 24 by 30, and the printer enlarges it so that it's a scale factor of 1.5. So notice it's greater than 1, it's going to be bigger. And then they take the second image and enlarge it again, this time by a scale factor of 3. What are the dimensions? Well, if you remember when we had the scale factor dilations way back in lesson 4 of chapter 6, all we had to do was take every coordinate times the scale factor. Well, these aren't coordinates, they're dimensions, but that's what we're going to do. We're going to take each coordinate times the scale factor. So it was 24 by 30. The first thing we have to multiply by is 1.5. And we get, let's see, that'd be 36, and double check me, by 45. So the first one is enlarged by 1.5, so my second image is 36 by 45. Then they enlarged that one by a scale factor of 3. So now I'm going to multiply them both by 3. And these are going to be big. 45, oh, let's see here. Let's see, 120, 35. So that one's 135 centimeters, and 36 times 3 is going to be 90 plus 18, so it's going to be 108 centimeters. So when we dilate something and then dilate it again, all you got to do is multiply by the first scale factor and then multiply by the second scale factor. But don't forget to do it to both of the dimensions. So that's how we use the scale factor. Okay, moving on then. Doing more examples. Are they similar? And if they are, we have to explain using transformations. But first we have to determine if they're similar. So take a look. Now, this is 2 rectangles. So realistically, I know you're supposed to compare all 4 sides, but if I compare those 2, aren't I comparing BC and EF? So AD is 2 to 3, and then AB 1, 2, 3, 4, 5. Over 1, 2, 3, 4, 5, 6, 7. Will those be equal? Well, that's 15 and 14 when I do cross products, so they are not equal, so they are not similar. Ratios not equal. All right, let's check out number 2. We've got 2 right triangles again. Not only are they right triangles, but I think they might also be isosceles. I'm throwing that word at you because remember, isosceles means 2 sides are equal. So EF is 3 and so is ED. So 3 over 3 and 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So 3 over 6 and 3 over 6. Those are the same, you guys. So whether we are saying ABC onto E, let's go ABC onto EFG or EFD. EDEF? There you go. So I'm going to say reflect triangle ABC to the left, then dilate by a scale factor of what? If I went from ABC to DEF, that scale factor would be 1/2 because I'm actually going smaller. All right. Moving on, slide number 3. Another one of those double dilations. We got a t-shirt iron-on. I don't know if any of you have made an iron-on t-shirt. So it's only 2 inches by 1 inch, so they're going to enlarge it by a scale factor of 3 for the back of the shirt. The second iron-on is enlarged by a scale factor of 2 for the front of the shirt. Okay, so interesting. It only measures 2 by 1. It's enlarged by a scale factor of 3, and then enlarged by a scale factor of 2 for the front of the shirt. So what are the dimensions of the largest? And are both enlarged iron-on similar? Well, yes, of course. They are similar because they're both being multiplied. So if it was 2 inches by 1 inch, the first thing we're going to do is multiply them both by 3 because that was the first scale factor. So 6 inches by 3 inches. And then we take that one and we multiply it by a scale factor of 2. So the original, or the one on the front of the shirt is going to be 12 inches by 6 inches. It is that simple. Don't overthink it. All right? Last slide for this one. I'm just going to let you practice. This one is interesting, and that's why I picked this one to do. Because we really only have one side that I can compare. I can compare AC to A prime, C prime. So let's see, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So 2 to 8. Well, if the new is 8 and the original is 2, what's our scale factor? It is 4. So I'm going to say, because it's on the coordinate plane, I'm going to I'm going to translate it down and over first, because if I am on the origin and I dilate it, guess what? It's going to stay on the origin. So I'm going to say, translate triangle ABC down 1 unit and right 1 unit, then dilate by 4. Now, if you dilate it by 4 first, it's going to be different, but hopefully you can get this last one. Just multiply by 1.5 and then multiply by 1.5 again. Good luck. Come see me if you have any questions.